So today is section 4.3, which still deals with solving systems of equations, but we're using a new method. So last time we learned the substitution method. This time we're going to use what's typically called the elimination method, but what our book calls the addition method. The addition method, that name makes sense. The elimination method also makes sense. So I'll kind of refer to it as both. Typically, it's called the elimination method. So if you've learned it before, and I'm sure some of you have, you would have probably been referring to this as the elimination method. So let's take a look at this first problem. We'll solve it using the addition method, again, or the elimination method. And between these two methods, really what you need to do is just make sure one of them makes sense. So if you remember what we did last time, the substitution method. This time we're going to learn the addition method. Both of these methods work on every single one of these problems in section 4.2 and 4.3. And sometimes one method will be easier than the other for a particular problem. So it's good to be introduced to both of them. And typically what will happen is students will feel more comfortable with one method more than the other one, which is fine. So just pick one that you're most comfortable with. On a test, I'm never going to say use this particular method. I'm just going to say solve the system of equations, and you can use whichever method you prefer. So look at this first one. With the elimination method, what we want to do, or with the addition method, is you want to add these columns. We want to add the x's, the y's, and the numbers. And we want to add them in a way where one of these variables drops out, either the x or the y. So with this one, you can kind of see by looking at it, if we were to just think of adding these together, x plus 5x is 6x. So if we did that, we would get 6x. Now when we add 2y minus 2y, that's just 0. They just cancel out. So these two just completely go away. This is where the name, the elimination method, comes from. We're eliminating a variable. Where the name, the addition method, comes from is we're adding these columns. So we're still going to get an equation, so we still need this equal sign to come down. And then 8 plus 4 is 12. So then we solve this for x, so we would divide by 6. And we would get x equals 2. Okay, so we've got half of our answer, right? Remember, with the system of equations, we need the solution for x and for y. So right now we have the solution for x. So to find the solution for y, we just substitute 2 into either one of these initial equations. It doesn't matter which one. I'll just pick the first one. So I'm going to put, where you see an x here, I'm going to put a 2 because x equals 2. So I'm going to put a 2 here. So I'll get 2 plus 2y equals 8. So now I'm solving for y. So I'm going to subtract 2 from each side. So that will cancel. We'll get 2y equals 6. And now to eliminate the 2, we divide by 2 and get y equals 3. So our solution is x equals 2, y equals 3. Or remember, the other way you could say it is 2, 3. Right? You could say 2, 3. What about this? Can you say 3, 2? Can you say that's the solution? Hopefully remember that you cannot do that, right? Because when you put it in this format like this, we're writing it like it's a point on the like on a xy plane. The point would be x comma y. Right? X is 2, y is 3. So it has to be in this order. It's an ordered pair. X first, then y. So what we did right there was we solved this using the addition method. And I'm going to do kind of like we did last time. There's these steps you can use that will work on any one of these problems when you're using the addition method. So just like before, remember in the last handout we had this for using the substitution method. Now I've got one for the addition method. So we go through these steps. So what I'll do is I'll solve this one, and I'll just kind of mention the steps as we go. And if you've never solved systems of equations before, you can just refer to these steps and it'll work on every one of these. So first we have to write both equations in standard form. Now we didn't have this before when we did the substitution method, but we have it now. It's got to be in standard form because we're going to line these up and add them. So we need the x to be first, then the y, then the equal sign, and then the constant. So this c will always be some constant like 7 or 0 or -3. It's not going to be a variable. We've got ax plus by equals c, so we need to do that first. And then what we want to do is multiply one or both equations by a number to create opposite coefficients for one of the variables. Because remember, we want the x or the y to cancel. Then we add the equations to eliminate one of the variables. We solve for the remaining variable. And then finally we substitute. And then the last step is we can check the solution. So to do this first problem, we've got, we look at these two equations. Step one, write both equations in standard form. Well, these are already in standard form, right? X, y equals constant. X, y equals constant. So step one, really, it's already done. There's step one already done. I'm going to check it off. It's already done. Here's something that happens sometimes. Like, what if we had 3x equals 5y plus 13? So a lot of times you'll see something like this, where this is not in standard form, right? So we have to first put it in standard form. So to put this in standard form, we would need to get this y over here. We need the x and the y on one side of the equal sign and then the constant on the other. So if this equation that we have here were written this way, we'd have to subtract 5y from each side to put it in this form. Okay, so they're not always going to be in this form, but in this particular problem, it's already done. Step one is already done because we have both equations in standard form. Okay, so step two says multiply one or both equations by a number to create opposite coefficients for one of the variables. So what we want to do is see which one would be the easy way. Like, I need to either eliminate the x's or the y's. The x's would definitely be easier because if you look at this bottom equation, we've got an x here. If I were to multiply this by -3, I'd get -3x, which is what I need to cancel. Whereas over here, it's a little harder because I can't multiply 2 by an integer to turn it into 5, which means I'd have to multiply this by a number and this by a number. Like, if I multiply this -2y by -5, I'd have a +10. Then I could multiply this by 2 to get -10, so they would cancel. So we need to either eliminate the x or the y. So the easiest way to do this one for step two, here's step two. The easiest way to do step two is to multiply the second equation by -3. Now when I do this -3 gets multiplied by everything here. Everything. Now just to see that won't change the answer, I want to convince you so you're not unsure about that. Let me get rid of this first. So let's say we've got, let's go x plus 3 equals 5. Okay, now everybody can see the solution here, right? The solution to this is x equals 2. That will make this true. So let's say I take this whole equation, x plus 3 equals 5. I'm going to multiply the whole thing by 7. I just made that up. Just change it. I'm going to multiply the whole thing by 7. So this 7 is going to get distributed all the way through on this side and on this side. So I'm multiplying each side of the equation by 7. So if this gets distributed through all the way, what we'll get is 7x plus 21 equals 35. So the question is this still the solution? And you can plug it in to see. If I plug in a 2 here, I'm going to get 7 times 2 is 14. 14 plus 21 is 35. So it's still a solution. So when you multiply the whole equation by a number, it doesn't change the answer. So that's why we're okay to do this. We can multiply this whole thing by -3, and it's not going to change the answer to this original equation, just like this didn't. Okay, so this is okay to do this. We have to do this to make the x's cancel. And it's okay to multiply by a number. You won't change any of the original answers. So I'm going to rewrite this first one here. And then I'm going to take this -3 and distribute it all the way through. And here's the key. I'm going to use red here just to make sure. So we go through here and here. And here's where everybody forgets. The number one mistake is to forget all about this 5 here. That also has to get multiplied by the -3. Because if you don't, then I'm treating this side of the equation differently than this side. Right? So I have to treat each side of the equation the same. So if I multiply this side by -3, this side also has to get multiplied by -3. So this kind of comes all the way through. So if you do that, you'll get -3x, right? -3x, then we have negative times negative. Negative times negative is positive. 3 times 2y is 6y. So we get plus 6y equals. And we get -3 times 5, which is -15. And now we're going to do step 3. Step 3 says add the equations from step 2 to eliminate one of the variables. Okay, so here we go. Here is step 3. We're going to add these together, and we're going to eliminate one of the variables. We know that because we purposely picked -3. Purposely picked it because we wanted the x's to cancel out. Right, so that's why, like for step 2, multiply one or both equations by a number to create opposite coefficients. Opposite coefficients, you got them. Remember, the coefficients are just the numbers in front of the variables. And these are opposite. 3 is the opposite of -3. So we do that because when we add these are going to cancel. And we get -5y plus 6y, which is just 1y, or y, equals 13 minus 15 is -2. So we have one of our answers, y equals -2. And then step 4, if you look at step 4, that's actually step 4 also. So add the equations to eliminate one of the variables. Step 4, solve for the remaining variable, which is basically what we did right here. This math right here is step 4. So it's getting a little cluttered here, but step 3, we just add the equations. And then this was already, step 4 was pretty much done for us. We didn't really have to do anything, but this would have been -5y plus 7y. Then we'd have 2y here, and we have to divide by 2. So step 4 just fell into place. There was nothing really to do. We just added them, and we had our answer to y. So then step 5, substitute the value found in step 4. So this value into either one of the original equations, either one, to solve for the remaining variable. So let me go back to the original equations. And I'm going to get rid of this a second. And it doesn't matter which one. We can pick either one of these. I just usually look for one that looks a little easier. In this case, I don't know if either one does, but I'll just pick the second one. So for step 5, I'm basically taking this -2, plugging it in to y right there. So step 5, we get x minus 2 times y is -2, equals 5. Right, so all I did, I'm writing this equation, but where I see a y, I'm plugging in -2 because y equals -2. So then you just solve, so you would get x plus 4 equals 5, right, because negative times negative is positive. If we want to get x by itself, we go -4, -4. That will cancel, and we get x equals 1. So that is the other part of the answer. So the answer is 1, -2. Or, of course, if you prefer, you can do it like this. And then this set of steps has the last step is check the solution, both original equations. And again, that's an optional step just like last time. But if you wanted to make sure this works, you could plug a 1 in here and then a -2 here and see if it works. And then do the same thing with the other one. Because you can't just check one. Because sometimes you'll get a solution where one solution works but not the other one because something went wrong. There's some algebra mistake. So when you check them at the end, you'll know for sure if you're right. Because if I plug a 1 in here, I'm going to get 3 times 1, which is 3. Plug a -2 here. -5 times -2 is +10, so I get 3 plus 10, which is 13. Right, it's going to be a plus because I have a negative here, -5, and then -2, so that makes it plus. Then I check this one, so I get 1 minus 2 times -2. -2 times -2 is 4, so you get, and it's a +4, so I get 1 plus 4 is 5, so it checks. Okay, so let's try one of these. This is one like you'll see. And so if we were in class, I'd have you guys try this, and then we'd work on it together. So let's have you take a little, press pause, and I almost said take a break, like we're in class or something. You guys hate that when I say take a break. You're like, no, I don't want to take a break. I know. So don't take a break, but just maybe press pause and see if you can solve it. But before you do, let me give you a little hint. This is not in standard form here. We need to have it lined up so that we can, like this one is lined up, C, D equals, and then constant. So to make it work, we need to have the C first and the D, just so these line up, right? So since this one's already good to go, you've got a variable, and equals a constant. So we want to put this one in the same form. So we need to do something. This -3D is on the wrong side of the equal sign. Okay, so try it out, and then come on back. So if you're back, and hopefully you did press pause and try it, we'll see that we need to do something with this equation. We need to put this in standard form. So I'm just going to write this equation down over here. And to get it in standard form, basically, I just need to get this thing over here. In other words, or to get the constant by itself. So either way you want to think of it, I'm going to need to add 3D to both sides of this equation. And of course, these are unlike terms, so you can't combine it somehow. So all we do is we have 5C plus 3D equals 17. So remember, there's always an equal sign, and the equal sign always comes down. So now this is in standard form. So I'm going to write this and replace this one. Okay, so I'm going to rewrite this original equation, or system of equations, and put our new one at the bottom, 5C plus 3D equals 17. So in this example, we have kind of like the worst case scenario. We don't have a number, or at least an integer, that I can multiply the 5 by to turn it into a -6. And same thing here, or the 6 turn into a 5. Same thing here. Like if this would have been a 4, this were 4D, well, I could just multiply this by 2 and it'd be -4D. So in this case, what we have to do is multiply both of these equations by a number to make either the C's or the D's cancel. In this case, most people would make the D's cancel because they're, as far as the difficulty goes, they're real similar, but because they're smaller, people tend to pick these. So plus they're already set up as opposite signs, right? That's a plus, that's a minus. So think, if I were to take this bottom equation and I'm going to multiply it by a 2. The reason I'm picking a 2, because I'm concentrating on the D. If I multiply 2 by 3D, I get 6D. 6D, right? So then if I take this upper one and multiply it by 3, when I multiply the 3 by the negative 2d, I get negative 6d. So I have negative 6d and 6d, so those will cancel. So I focused on the d. You could also focus on the c. Like I could have multiplied this one by, say, negative 6, and this one by positive 5 to make a 30c and a negative 30c, which would also work. But I'm just going to pick these to get rid of the d. So just have to remember, you distribute here, and don't forget about this one. The number one mistake here is forgetting about this. I can't multiply this side by 3 without also multiplying this side by 3. Right? That's how equations work. Whatever you do to one side, you have to do the same to the other side. So I'll distribute the 3 all the way through the equation. And on this side, distribute the 2 all the way through the equation. So that when we're done, the top equation will be 18c minus 6d equals negative 6. And the bottom equation will be 10c plus 6d equals 34. So then at this point, the addition method, right, we're going to add these columns. I'm adding. 8c plus 10c, that one's pretty easy, 28c. Negative 6d plus 6d, well, we purposely chose those because we know they'll cancel. Now remember, I still have an equal sign. It's an equation, so I'm going to have an equal sign here too. When you add two equations, you get another equation. Then negative 6 plus 34 gives us 28. So 28c equals 28. So that's an easy equation to solve. Divide both sides by 28. And you get c equals 1, which means we got half of our answer. Now we just need to figure out what d is. So once you have the first answer, just go back and pick either one of these. It doesn't matter. Plug c equals 1 in for one of these c's and see what you get. So it doesn't matter really. I'll take this one and move it down here. So 6 times c is 1, minus 2d equals negative 2. So this is 6 minus 2d equals negative 2. I want to get d by itself, so I'm going to subtract 6. That's gone, so you get negative 2d equals negative 8. Negative 8, right? Because if you start with negative 2 and you subtract 6, like if you're $2 in debt and you borrow another $6, now you're $8 in debt. I want to get d by itself, so I divide by negative 2. Oh boy, I don't know. It don't happen to that negative 2. Very bad. By negative 2. So then that cancels, and we get d equals 4. 4 because negative divided by negative is positive. So if you wanted to check, you could. I'll let you do that on your own, but basically just plug in a 1 for c and a 4 for d, and you have to check both of them, and they should check out. Okay, so there's a couple examples. Right now I would normally take a vote and see who likes the substitution method and who likes the elimination method, and it's almost always about a 50-50 thing. So use either one. Both of them work for every single problem. Like I said, sometimes one method will be easier than another for a particular problem, but they both work for all of them. So this one, as you remember, there's those two weird solutions. Remember from section 4.1, we did the 3 graphs. The weird solutions are when you have, or the weird situations are when you have either no solution, which means the lines are parallel, or you have infinitely many solutions, which means the lines are the same lines. And by lines, I mean if you were to graph these equations, right? It's a linear equation, so you could graph this equation of a line. You could put it in slope-intercept form by adding 2x, right, to each side. Same thing here. You could graph this equation, and what we typically get when we solve it and we get one solution means that these lines, if we were to graph them, would intersect in one point. But I want to make sure you see the kind of the weird method, or the two weird situations. So let's take a look at this one. So this one if we were going to solve it, we'd want to eliminate a variable. And this one's pretty easy, the x's and the y's, but one thing that's a go-to is when you have a variable by itself, because then it's really easy to turn this into the opposite of this, right? This is negative 4y. I could multiply this by 4 and get positive 4y. So elimination method, most people would multiply this top one by 4, because that would cause this term to be a 4y, which would cancel with that term. So I just distribute this through all the way. Remember, don't forget about this one over here. So what we get, if I rewrite, I get negative 8x plus 4y equals negative 20. Right, and that is just from distributing the 4 through all of this. And on the bottom one, we've got 8x minus 4y equals 12. So we go ahead with the addition method or elimination method. We add this, negative 8x plus 8x is 0, so that's completely gone. Right, that's gone. And then we have 4y minus 4y, and that's gone. So what we have on this side of the equation is just 0, right? Everything drops out. We just have 0 equals negative 8. Now at this point, it's the same as the last time. We noticed that. Weird things. The variables are all gone, and we get a false statement. False statement. It doesn't have to be 0 equals negative 8. It just had to be something that's not true. Could be 0 equals 4, 3 equals 8, anything. If it's false, think of it like this. When is 0 ever going to equal negative 8? Never. And you're never going to have a solution. There's no solution. If you were to graph these lines, they're parallel lines. So the answer to this question is this. The answer is no solution. Right? The other oddball answer is infinitely many solutions. And that would happen if we would have went through and the x's and y cancel out and we get a true statement. If we had negative 8 equals negative 8, I would say true statement, and I would say infinitely many solutions. Right? So that part's the same as the last section. So the book would say, okay, this is an inconsistent system. I'm not going to ask you about it, but you'll see it in the book. I'm just going to say solve the equation, and the answer to this one is there's no solution. That's the answer. As soon as you get this weird situation here where the variables drop away and we just get an equation left with no variables, all we need to ask ourselves is this a true statement or a false statement? In this case, it's a false statement, which means there's no solution because these lines are parallel. So that takes care of the second method for solving these. Really 3 methods. 4.1 showed the graphing method, but nobody really uses it. The important methods are the substitution method from 4.2 and this addition method, also called the elimination method, from 4.3. So keep working at them and let me know if you have any questions.